draw and label apparatus that could be used to extract copper from copper oxide in the lab. Now, there's a couple of ways we could do this. First off would be combining two of the core practicals we've done this year. This is the less obvious way, I think. You could take copper oxide, which is insoluble, and react it with sulfuric acid to make copper sulfate. We'd filter out, if you remember, the excess copper oxide. Then with that copper sulfate, using our second core practical, we could do electrolysis and you would get copper liberated at the cathode, but I think that's probably a bit less obvious and a bit tenuous. I think probably what the examiner would expect to see here would be knowledge of the extraction of metals module. Now, to do that, you need to remember that copper's got a fairly low reactivity. Now, metals with a fairly low reactivity we can extract by displacement with carbon. Carbon's quite a reactive non-metal and it's very common. So if we heat the metal oxide, the copper oxide, with carbon, then that will displace the copper. Now, to do this displacement, we have to heat the mixture of copper oxide and carbon really quite strongly. So I've drawn myself a tripod here already, and we're going to label that arrow there heat, and that's how we signify a Bunsen burner. So what we're going to need on here, we're going to need ourselves a pipe clay triangle and a crucible. So let's label up our crucible here. Okay. Now that crucible, and the crucial thing to here is going to say what it contains. It's going to contain copper oxide mixed with powdered carbon. Now, it would be a good idea, I suppose, to put a lid on that, because we obviously don't need to get the oxygen in there, because the carbon is going to take the oxygen from the copper oxide to leave copper all on its own. So let's put our mixture in here as well. Let's just signify that's our mixture, and let's get that arrow going into there. And we've obviously got our lid, and there we go. That'll be our 2 marks. All these questions and more on eltramhighchemistry.com.